In the last two videos, we covered the first two situations in which a person creates a confidence interval. Those two situations were creating a confidence interval for a mean when the population standard deviation is known, and creating a confidence interval for a proportion. In this video, we'll cover the third confidence interval situation, which is creating a confidence interval for a mean when the population standard deviation is unknown. So let's go through an example of that situation. So here we have a population. The mean age of the population is unknown, and the population standard deviation should also be unknown. Pretend like you can't see it here. I think I just put it there by accident. This is the shape of the population. The ages have a positive skewness, so most people are down here in this area. Someone takes a random sample of 35 people from the population and records their 35 ages, and the person gets this data set right here. The first step is calculating the mean of the sample. To get the sample mean, you just calculate the mean like you always would. You add these 35 ages and divide by 35, and this is the answer to 2 decimal places. Next, we need to know if a margin of error can be calculated. Since a mean is being calculated, we have this checklist right here. There's a different checklist for when a proportion is being calculated. So the population has to be normal or bell-shaped, or the sample size has to be 30 or larger. The population isn't a normal distribution, but the sample is 30 or higher. So this checks off, and in this checklist, only one or the other has to check off. They don't both have to check off. So since this checks, this answer is yes. Next, we calculate the 95% margin of error. In this third situation, in which the population standard deviation is unknown, we don't use a z-score anymore. We look up something called a t-score from something called the t-table. So we're not going to be using 1.96 anymore. We're actually going to be using a t-score, which is an adjustment to that 1.96. It's an adjustment. It's adjusted to make a correction for us not using the population standard deviation. So you have to go to something called a t-table to look it up. I'll share a t-table with you. I'll send it through a message. The 95% confidence is actually at the bottom of the table. When you look at the table, you'll see all the confidence levels across the bottom. You need to go to 95. The rows are labeled by the sample size, but they're actually um, not technically labeled by sample size. They're labeled by something else called DF, or degrees of freedom. So DF, or degrees of freedom, is actually one less than the sample size. So if the sample size is 31, DF is 30. And I guess in this case, we have 35 people, so DF would be 34, which would mean we should be going to row 34. But I guess in this case, row 34 isn't available, so we just go to the closest one, which happens to be 30. Just go to the closest one if your row isn't there. And DF is actually the name for the n-1 that we used to calculate the sample standard deviation a long time ago. So back then we were dividing by something called a DF, and it's just n-1. Like I said, our DF is actually 34, so we should be going to row 34, but 34 isn't there. So we have this row, we have this column, this is our t-score, and this is what we plug in as the substitute for the z. Next we have to calculate the standard deviation of our sample. Since we don't know the standard deviation of the population, we have to calculate the standard deviation of our sample as an estimate, or a best possible substitute. So what we do is we have to plug in this data into the standard deviation formula using n-1. And if you did it by hand, you would have to do it like we did a long time ago. Subtract each number by the mean, square the answers, add, divide, and get the square root. But since This data set is pretty long. It makes more sense to just go to a calculator to get the standard deviation, and it's 1.42. S stands for sample standard deviation. That's why it says S. Sigma is population standard deviation, which is actually unknown. Pretend it's not here. Next, we go to the formula, which is T times the sample standard deviation over square root of n. So we have all three numbers now to plug in. The T from the T table, the S, which we calculated, the standard deviation, from an online calculator, and n, sample size, 35. This isn't n minus 1, it's just regular n, 35. The n minus 1 is just something that went into calculating this 1.42 standard deviation. Um, if I showed you all of the steps that were followed to get this 1.42, you would see the n minus 1 in there. So this n minus 1 is just one of the steps that happened along the way toward the 1.42. Next, we get our margin of error, 0.49. In part D, we take our sample mean from part A, we add and subtract the 95% margin of error, and we get our two answers. And that's our interval, and we write our conclusion like we've been doing. In this case, we're 95% confident that the population mean, or the mean age of the population, is between here and here, the two numbers that we found in part D.